Alright, so as I said, chapter 6 talks about quadrilaterals, which today we're going to focus on parallelograms. But quadrilaterals, quad means four, lateral means side, so four-sided figures. And they use the word exploring because it sounds so much more interesting. So here's your definition of a quadrilateral. A closed four-sided figure. And the assumption is that they're all straight sides. No curves to those sides. Because a quadrilateral is a polygon. And remember, the definition of a polygon was a closed figure with straight sides. So this is a four-sided figure. We're going to specifically look at the parallelogram today. Parallelogram is a special quadrilateral where two things occur. Both pairs of opposite sides are parallel. And I've drawn a picture of that there. Well, more than two things are going to occur. You're going to see a lot of stuff going on here. So that's your first thing. And then that notation there with those arrows just show you that these two lines are parallel and those two lines are parallel. And don't we know a whole bunch of important things with parallel lines? Doesn't this side act as a transversal? So we end up having consecutive interior angles in there. So you should already know something about the angles inside that parallelogram. Are all quadrilaterals parallelograms? Are all quadrilaterals parallelograms? No. Are all parallelograms quadrilaterals? Yes. So remember those questions that I was asking you regarding different types of triangles? Those same type of questions are going to come into play here. And the only thing that's going to make this test difficult is if you don't have a clear understanding of the difference between a quadrilateral versus a parallelogram. The difference between a parallelogram and a rectangle, difference between a rectangle and a square, and so forth. You have to know those differences inside and out. And they're not difficult concepts, you just have to study them. All right, here's the next one. So theorem 6.1, again, you're not allowed to memorize the theorem, but what it says that the opposite sides of a parallelogram are congruent. And I've drawn a little picture with tick mark notations here to note that. So in addition to the opposite sides being parallel, they're also congruent. In order for both pairs of opposite sides to be parallel, both pairs of opposite sides have to be congruent. So that is characteristic number 2. All right, characteristic number 3. Now I'm going to pull this down just a little bit. Opposite angles of a parallelogram are congruent, and I'll prove that to you in just a minute. You do have a set of obtuse angles and a set of acute angles. But there's only two different types of angle measurements in that parallelogram. So as you can tell by that theorem, you're going to have some algebraic equations to set up regarding that characteristic. Let's say that this angle measure here is 120 degrees. And these are parallel lines. Isn't that the transversal? What type of angles are these? Yeah, but what type are they called? Consecutive interior angles. And what do you know about consecutive interior angles? That they're supplementary. So if this is 120, what's this one? 60, right? Subtract 120 from 180, you get 60. So now, you can turn your paper, I can't turn the board, but now these lines are parallel, right? And that's the transversal. So aren't these also consecutive interior angles? And aren't they also supplementary? If that's 60, what's this? 120. And then, again, those are parallel. So these are consecutive interior. And if that's 120, this is 60. So aren't opposite angles congruent? So I'd write that in there on that big one. So that's your proof, and that's why. Remember, it's a theorem, so there is a formal proof behind it. And that's essentially what that formal proof does, is it talks about the parallel lines and the consecutive interior angles. So then 6.3 says that consecutive angles in a parallelogram are supplementary. Well, no duh, we just proved that, right? So that is your fourth characteristic. But one more to go, maybe two. All right, so here are some quadrilaterals that are not parallelograms. And I put diagonals in them for reasons so you could look at them. Three of those are parallelograms. The one that I have noted is not. What do you notice about the three that are parallelograms and their diagonals with those tick marks in there? Anything come to mind? What do you notice about this and this? What are those tick marks telling you? That they're congruent. What about this and this? That they're congruent. So what have the diagonals done to each other? They've bisected each other. Have they done that over here? This is a square over here. Have they done that over here? Yep. This is just a rectangle, and they've done that here. This is a rhombus. Notice that although the diagonals are different lengths in the rhombus, haven't they also bisected each other? And then I put here a definition of what I consider a diagonal. Diagonal of a polygon are the segments that connect any two non-consecutive vertices. Because if it tried to connect consecutive vertices, you're talking about the side of that polygon. So doesn't that lead you to your last characteristics of the parallelogram? The diagonals of a parallelogram bisect each other. Anybody else still writing? Would you be upset if I took away? Okay, I'll give you a minute. Are we done? Anybody else upset? Okay, here it goes. All right, so then you're going to have some problems, algebraic problems to deal with. And example 1. And this is a very simple one. They do get a little bit more difficult. MATH, math, ha ha ha, is a parallelogram. So the minute they say that something's a parallelogram, they told you a whole wealth of knowledge, or they've given you a whole wealth of knowledge. 6 characteristics there that you should be aware of. Anything goes. And by the way, when we name a quadrilateral, and they specifically name it MATH, you have to name that quadrilateral going clockwise or counterclockwise. In other words, I can't name one vertex M and go diagonally across the diagonal and name the other vertex A. If you do that, because sometimes they're not going to give you a picture, if you do that, you're going to end up getting the wrong angle measures in the wrong place. So you have to go in a circle, either clockwise or counterclockwise. And then this one goes on to say, find the values of W, X, Y, and Z. And your picture looks like this. So using your knowledge of those 6 characteristics, I want you to think about that picture and write down what X is, what Y is, what Z is, and what W is. And then next I want you to say why. Like for instance, what's the value of X? 15, why? Why do you know that? Because, there you go, opposite sides of, and you can use now a little parallelogram, are congruent. So I want you to do that for W, Y, and Z. Yes. 55 degrees. Pardon? I can't hear you. M, yeah. MA is 15. That's how I got X being 15. Opposite sides are congruent. Y'all need distance glasses. And you're a pitcher. You can't see that far away? You have to see the little mitt and you can't see that far away? Oh my, you need to redo them. When you get your answers, compare them with those around you. All done. Thank you. All right, so when you get all your answers, compare and talk about why, because there's a couple of them that you could have different reasons why. Discuss why. All right, what did you come up with for W? Is that your reason why? So I said W is 125 degrees because consecutive interior angles in a parallelogram are supplementary. Or you could have said consecutive interior angles on parallel lines are supplementary. You could have said that too, because you do have parallel lines because it's a parallelogram. What'd you say about Y? 55? And again, it depends on what you said for this one. I said 55 degrees because opposite angles are congruent in a parallelogram. That's the easiest reason to say why. You could have said that consecutive interior angles again are supplementary, so you could have used that one again. What'd you say for Z? It is also 55. Here's my reason. Isn't Z and Y, aren't they alternate interior angles on parallel lines? That's my reasoning. You could have used these two as your reasoning. What would your reasoning have been for these two? Corresponding angles are congruent on parallel lines. Right? those are the quicker ways to get around them. You wouldn't have wanted to say that consecutive interior angles are congruent because you haven't found that one yet. Or that it's a linear pair because you haven't found that one yet. Does that make sense? All right, so there's that. And the last one I'm going to give you, you're going to have some kind of mini proofs in this, and it will come back to haunt you on your test. You'll forget about it because it'll be a while since we got to it. You will be given angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. Determine if quadrilateral ABCD is a parallelogram. So you have to use one of those defining characteristics of a parallelogram. What is the definition of a parallelogram? What was the first thing I gave you? It wasn't a theorem. There you go. So the definition of that parallelogram said that both pairs of opposite sides are parallel. That's one of the main ones that I'd like to try to use. And so here's your picture. So this is like a little mini proof. What do I like you to do before you do any kind of proof? Pre-proof planning. So let's see what they gave us. So they gave you that angle 1 was congruent to angle 3. So I would use arc marks. Single arc marks at 1, single arc marks at 3. And then they said that 2 is congruent to 4. I don't know that 1 is congruent to 2. All I know is that 2 is congruent to 4, so I'm going to use double arc marks here. So, if I'm trying to prove that opposite sides are parallel, look at these two lines right here. And this is my transversal. What can I use to prove that those lines are parallel? Angle 1 and 3 or angle 2 and 4? Which angle measures are not inhibited by these sides here? Seth?
Well, if they're alternate interior angles, those are only congruent when there are two parallel lines.
Right. So which two sets of angles am I going to use? Am I going to use 2 and 4 or 1 and 3? Yes, it does. Yeah, it does. Which angles are impeded by these sides? In other words, cut off. 3 is, right? And 1 is? Because if these sides were gone, wouldn't I have this line all the way out to here? If these sides are gone, then these lines would extend infinitely all the way out to here, wouldn't they? Angle 2 and angle 4 will remain the same angle measure, won't they? But if these lines are gone, then won't angle 3 be an obtuse angle? It currently is not. So do you see how 3 and angle 1 are cut off by these additional sides right here? You have to ignore those. These are not the correct angles to prove these sides parallel. So the correct ones for these sides are angles 2 and 4. So we're going to start with there. And then if you look at these sides, now you have to ignore these ones. So if you look at those sides, and I'm going to go ahead and turn my paper. It's easier to see when it's turned this way. So if I look at these sides, which angles are cut off by those sides right there that we have to ignore? Yeah, the 2 and the 4. The 3 and the 1 are the same measure whether those sides are there or not, and that's what you have to look at. And so 1 and 3 are used for these sides, and 2 and 4 are for the other. And so it's really important when you talk about those that you put the right angles together with the right sides. So, here we go. Since alternate interior angles are congruent on parallel lines, and I'm going to put in parentheses here, angle 2 is congruent to angle 4, then line AB is parallel to line DC. So that's one of them, right? In addition, alternate interior angles are congruent on parallel lines. And then in parentheses, we're going to put the angle 1 and angle 3. And I'm going to put the word since in here. In addition, since alternate interior angles are congruent parallel lines, then line AD is parallel to line BC. Therefore, quadrilateral ABCD is a parallelogram because both pairs of opposite sides are parallel. So that's a mini paragraph proof. You've stated that you have two sets of alternate interior angles that are congruent. You've stated which lines are parallel because of those congruent angles. And because of that, you're able to state that the quadrilateral is a parallelogram because both pairs of opposite sides are parallel. So then take out your pink sheet that I just gave you. We're going to summarize all of this by writing down what we've learned today. Alright, so starting with quadrilaterals, what have you learned about a quadrilateral? It's a four-sided closed figure, right? So it is a four-sided closed figure. That means that everything below this is also a four-sided closed figure because they're all quadrilaterals that we're looking at. So then today we specifically looked at a parallelogram. So my parallelogram is in blue. First characteristic, what did we say? Very first thing, what was the definition? Yeah, opposite sides are parallel, right? And you might want to put in here that this is the definition. So opposite sides are parallel. And then the second thing we looked at was what? Opposite sides are what? Yep, opposite sides are congruent. While we're on opposites, we'll go with 3. Opposite angles are what? Are also congruent. And then 4, what did you learn about consecutive angles? Consecutive interior angles are what? Yeah, supplementary. Number 5. What else? What's the last thing? Something about diagonals. Diagonals bisect each other. Now, any one of these can come into play in setting up an algebraic equation to solve any of these parallelograms today. We're going to get to one more, and I'm going to go ahead and have you write it on here today. But another theorem that you're going to run across is that if you can prove that only one pair of opposite sides is parallel and congruent, you can prove that it's also a parallelogram. Only one pair. If you can prove that one pair of opposite sides is both parallel and congruent, then the other pair is going to have to end up being parallel and congruent too. But you only have to prove one of them. So that's it for today. So your homework is both out of the book and a practice worksheet.